The next reaction in this section, 23.5, is called the Azide Synthesis. This is another SN2 reaction using a nucleophile that we don't use very often, so it's probably going to be pretty unfamiliar to you. This is any alkyl halide reacting with azide, which is an anion. It's usually combined with sodium, so NaN3 sodium azide. That would be a really common way to see it written. It's going to give you this RN3 intermediate, and that RN3 intermediate, which I'm going to draw the structure out in just a minute, that can be reduced with LAH followed by water, reduces it down to an amine. You can also get this reduction done with hydrogenation, so H2 with one of our metal catalysts like platinum, palladium, nickel. And before we get into the mechanism, let's make a note that our alkyl halide that we start with can't be tertiary, because this is the first step of this reaction is an SN2 reaction. So we're going to look at a specific example and also draw out the mechanism of how this works, because it does look kind of magical as you're going from, this first step to the second step, losing a couple of nitrogens, what's going on there. So I am going to draw out the azide ion, the N3 ion, N3 minus ion. So it's three nitrogens that are all double bonded together. The nitrogen in the center has a positive charge, and the nitrogens on the end each have a negative charge. They each have 2 lone pairs of electrons. So this is a good base, and it's going after our carbon with the bromine on it. And the first thing that we make is the RN3. I got excited with my bonds there. RN3. Remember, we still have, since we haven't done anything to the middle or the last nitrogen, they still have their formal charges, and the last nitrogen still has its 2 lone pairs. Nitrogen up front has 1 lone pair. And then the next thing that's going to happen is the hydride reduction. Remember, LAH is a source of H-. That H- ion is going to be attracted to the first nitrogen. Now, I'm going to try to find a good way to draw this. It's not, be really careful, it's not being attracted to the lone pair of electrons on that nitrogen. It's being attracted to the nitrogen in itself. The negative charge on the hydride is not going to be interested in going after a lone pair of electrons, which are also negatively charged. So when we do this first step, we are going to end up, we've got to be really careful. We've got a hydrogen on the first nitrogen, and it still has its lone pair, and it now has a single bond to nitrogen number 2. Nitrogen number 2 has now a lone pair, and then the nitrogen out on the end is still 2 lone pairs with a negative formal charge. So then we get a little bit of internal rearrangement here. One of the lone pairs from the end moves in. It's going to make a nitrogen-nitrogen triple bond, and that is going to allow the nitrogen-nitrogen single bond to break. And we end up with 2 lone pairs on that nitrogen, a negative charge on that nitrogen, plus we have also liberated N2 molecule. So this is a gas that's just going to go away. And then to complete this reaction for step 2, we are just simply protonating that negatively charged nitrogen. And we have our product.